We actually can't. There's a specific window, and it's this week. So we can't push it to after.
Why not?
Because there's a window that it has to be done by. All right. You ready? Okay, look at your FRQ. Yes? Oh. Okay, part A says some stuff. Okay? Okay, part A says, what are the signs of dx dt and dy dt in quadrant 1? Okay, question, what does dx dt stand for? Okay, the derivative of x, or to put it into words, it'd be the rate that your x is changing, yeah? So I'm going to put a little arrow. That is the rate that the x value is changing. Now, I care about quadrant 1. Notice they even drew a little point for you. And then they told us that it's rotating counterclockwise. And in case you didn't know that, they even put a little arrow. What is happening to my x value as I move from this point to this point to this point to this point? It's getting smaller. Then what is the sign of dx dt? It's negative. Very good. Dx dt less than 0, or you could have put is negative because your x values are decreasing as you move around the circle in the direction that they told you to move. Now, what about your y's? They're increasing. So what must dy dt have been? Greater than 0. Because your y values are increasing. Now, that's kind of a conceptual question, okay, but what about in quadrant 2? So that would mean that I'm on this part of the circle. I'm still going counterclockwise. What are happening to my x's? They're still decreasing. What about my y's though now? They're going down as well. So for this one, I would put dx dt and dy dt are less than 0. Because your x's and your y's in that quadrant are both decreasing. Okay, I'm going to put here traveling left and traveling down. So you have to kind of think about the x's and the y's separately as your point travels around the circle. Okay, then part B. Find given when. The equation was given to us up here at the top, so I don't have to rewrite that. What are they asking me to find in part B? dy dt. What was I given? dx dt, what is it? Negative 2. Look, they didn't even try to trick you or anything. Okay, they just told you it's negative 2. Then what is my when? What is x? 4, and y is 3. So they kind of put it together in a point, but that tells me that x is 4 and y is 3. Okay, then from there, I'm going to take the derivative of my equation. So remember, my equation was x squared plus y squared is 25. Now, you would not have to rewrite that, okay, but it's Pythagorean theorem, so you should have been able to if you needed to. What's the derivative of x squared? 2x dx dt plus dy dt. Oops, hold on. Crap. 2y dy dt. And then what's the derivative of 25? 0. Then from here, we're just plugging stuff in, yeah? So it'd be 2x is 4, dx dt is negative 2, 2y is 3, dy dt is unknown. Remember, on the other side, the derivative of 25 is 0. Then from here, 2 times 4 is 8, times negative 2 is negative 16. That's a 6 dy dt. So then what would my next step be to solve that? Add the 16 across to the other side so that 6 dy dt is positive 16. And then my last step, I would divide by 6. Make sense? Now, do you have to reduce? No. Could you reduce? Sure. Doesn't matter. Okay, part C, find given when. Okay, if you have not already filled out the find given when, I want you to try. So read through part C. Okay, consider the triangle formed by 0, 0, x, 0, and y, 0. So I'm going to use the point that they gave me. Okay, this is x, 0. This is y, 0, y. And then this is 0, 0. So if I connect those, I see that I've made a triangle. Okay, then it says that I want theta to be the angle formed by, it says, the hypotenuse and the horizontal leg. So when I draw my theta in, I'm going to draw it here. Now, you should never make theta the right angle. So you're really down to a 50-50 shot at the two angles that are left. It will never be the right angle, or else you don't have your opposite and your hypotenuse come out to be the same side. Okay. Now, this is where we have to think about what are we finding. Find the rate of change of theta, so d theta dt. Then my given, I know dx dt is -2, and I now know that dy dt is 16 over 6. Okay, because I found that in part A. Then for my whens, I still know that x is 4 and y is 3. Okay, this is where you need to think ahead of time before you pick your trig equation. Okay, I'm going to come back up to the top. I want you to think about which one you should pick. Sine, cosine, or tangent. Don't say it out loud, but think about your choices carefully. Okay, I'm going to come back up to my picture here. Okay, this side is x. This side is y. What is this side? 5. Is it sometimes 5 or always 5? Always 5. Then you want to pick that side. This is why. If I pick tangent with y over x, I'm going to have to do what rule? Quotient rule. That sucks. So don't pick that. Okay, out of my choices, I could do sine or cosine, yeah? Which one did they give me the ddt for, x or y? Which one did they give me, not that I found? Dx dt. So I'm going to pick this side. Okay, but you could pick y and 5. Here's the only problem. If the number you got is wrong, it might make your answer not come out as neat. Versus usually if they gave you the answer, they make the numbers come out to where it's reasonable. So for my theta, I'm going to pick tan theta equals, I'm sorry, not tan. Which one did we choose? Cosine, thank you. Adjacent, which is x, over hypotenuse, which is 5. Now, when you look at that, it looks like a quotient rule, but I'm not going to leave it like that. How am I going to use it when I take the derivative? This side. 1/5 x, yeah? So remember, I can do this. 1/5 x, and not leave it as a fraction. So I'm going to come back down to my part C. My equation is going to be cosine theta equals 1/5 x. Okay, what's the derivative of cosine theta? Negative sine theta d what? D theta dt. Remember, you get no points if you forget that if it's a related rate. And then what's the derivative of 1/5 x? 1/5, and then what? Dx dt. Good. Okay, then I go to evaluate my sine theta, and if I don't know theta, then I have to use the sides of the triangle. That's the whole point. Use the sides of the triangle. So which sides can I replace for sine? Which two? Which ones? SOHCAHTOA. Opposite over hypotenuse, yeah? So what's opposite? Which number? Y was 3. And what's my hypotenuse side? 5. What have I done wrong so far? It was a negative. Don't forget that negative is part of the formula. Then from there, I have a 1/5 dx dt. Oops, what was dx dt? I'm going to sub it in. -2. Good. Okay, then from here, how would I get rid of a -3/5? Very good. I'm going to multiply by -5/3, -5/3. So that way, these guys cross out, and these guys cross out. So my d theta dt is by itself. Now, do we notice anything else that's going to cross out on the other side? Okay, my negatives I heard, that's correct, and my 5s. So really, all I'm going to have left is what? 2/3. Do you even have to simplify to get to 2/3? No, you don't. Okay, if you left it as a 5th, -2, -5/3, that would be good enough. You would get full credit. Now, quick question. Our d theta dt came out positive. Think about my picture for a second. As I move my point over, is my theta going to be getting bigger? Yes, so that makes sense in the picture, that as I move that point up higher, my theta is going to be opening up, so my theta is increasing. That makes sense. Good? Okay, so put that to the side, and we're going to look at your packet. We're not going to do all of these. Most of them you can't even do. We're going to just try to get through 2 of them. Look at number 5 with the funnel, please. Right here. You cannot do parts A or part B. Those have integrals in them, so if you take it home, don't try to do them. We haven't learned how to take integrals yet. Okay, those are second semester. So we're only going to do part C. So what I want you to do is write down find, given, when, and then our equation was already given to you. It's right here. Okay, I got it right there. Okay, so I'm going to read it to you, and I want you to listen for the find, the given, and the when. It says the inside of a funnel of height 10 has circular cross-sections as shown in the figure above. At height h, the radius of the funnel is given by, they gave you an equation, then it says where 0 less than or equal to h less or equal to 10. R and h are in inches. Okay, part C. The funnel contains a liquid that is draining from the bottom. At the instant when the height of the liquid is h equals 3, the radius of the liquid is decreasing at a rate of 1/5 inches per second. At this instant, what is the rate of change of the height of the liquid with respect to time? Okay, the with respect to time is what should hint to you that this is a related rate. Okay, so what am I finding? Great, dH dt. What rate was I given? dr dt. What is dr dt? A 5th? -1/5. Very good. And where does the negative come from? That it says it's decreasing. Very good. Okay, then what is my when? When h is 3. Yeah? Okay, so take a look at your equation. Right now, what rule does it look like I'm going to have to use to take the derivative on this side? Product rule. But if it's a number in the front, can I just distribute it in? Yeah? So I'm going to simplify first and distribute the 1/20. Okay, because I don't want it to look like a product, and I don't want to have to do product rule. So what would my new equation be once I times in the 1/20? R equals what? Okay, 3/20 plus. Okay, I'm going to do 1/20 h squared, but that's the same. Okay, take the derivative of that. What's the derivative of R? dr dt, very good. Now, how do I know it's a dr dt? Because it's the radius with respect to what? Time. That's why it's a dt at the end. What is the derivative of 3/20 if it's a constant? 0. What's the derivative of a 20th h squared? Okay, 2/20. What's the new power on h? It used to be squared. Now it's a normal h, and then times a what? dH dt. And then from there, what's my drdt? Negative 1/5, 2/20 from what we're doing your packet. And it's like the back of the first page. Okay, and then what was my h they gave me? 3, and then my dHdt is what I'm solving for. Okay, now if you want to be really lazy, look, dHdt equals negative 1/5. How would I get rid of my 2/20? 20/2. How would I get rid of my times 3? 1/3. Could I leave it like that? Sure. Now, if you didn't want to do that, okay, you could have done this. That would have been 6/20 dHdt. And then you could have solved it by doing negative 1/5 times 20/6. Okay, it doesn't matter which way you choose to solve it. This is fine. This is fine. It's really just a matter of how comfortable you are with fractions. Okay? Next one I want you to turn to is the one about a stump and a tree growing. I think it's like the very last one. Hello? Who? I do have to. Can I send her after, like towards the end of the period? Okay, thanks. Bye. Jessica, Miss Camacho wants to see you. She's one of the assistant principal secretaries. I think it's about this ice cream thing they're doing. Very exciting. They'd like to give you an invitation. Just near Miss Gibson's office. No, just go at the end. Okay, so we're going to this one. You cannot do part C. The other two parts you can do, but I just want to focus on part D, okay? So it says, the height of the tree in meters can also be modeled by the function g of x equals blah, 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 where x is the diameter of the base of the tree in meters. When the tree is 50 meters tall, the diameter of the base of the tree is increasing at 0.03 meters per year. According to this model, what is the rate of change of the height of the tree with respect to time in meters per year at the time when the tree is 50 meters tall? Okay, this one's harder, but it's not too hard. You got to think one thing at a time. So let's think about what we're finding. Okay, it says, according to this model, what is the rate of change of the height? I'm finding dHdt. Very good. Okay, read back through it. It told me how fast something was changing. What do we know is changing? Okay, the diameter of the tree. Now, you might want to pick ddt for diameter, but they gave you a specific letter. What letter is going to be the diameter here? X is the diameter. So if I know that the diameter of the tree is 0.03, that's really what? dx dt, yeah? And then it's 0.03. How do I know it's positive 0.03? Because it said what? Increasing. Okay, then what's my when? When the tree is 50 meters tall, which letter is that, X or H? H is 50. Okay, now let's look at our equation. They labeled it g of x, but what does it stand for? Height. So they're trying to confuse you by picking a different letter. But I'm not going to be confused, neither are you. Okay, the height is 100x 1 plus x. They can call it whatever letter they want. Okay, but I'm going to relabel it in h because that makes more sense to call it h if it's height. Okay, now when I take the derivative, what rule am I going to need to use on the 100x side? Quotient rule. So I'm going to give you a minute. Okay, you just did one like this on your quiz, either just a second ago or yesterday. You can show the work if you need to, or you can do it in your head. High is 100x. Ho is 1 plus x. What is my d high? 100 what? dx dt. What is my d ho? What's the derivative of 1? 0. Derivative of x is dx dt. Very good. Or 1 dx dt is fine. Okay, set up your quotient rule. It'll be dh dt equals. And then remember, I need to do ho d high. So that'd be 1 plus x 100 dx dt minus for quotient rule. Some of y'all missed that on your quiz yesterday. Okay, and then high d ho is 100x dx dt over ho squared is 1 plus x squared. Okay, then I get ready to plug stuff in. I'm finding dh dt. I notice that's already solved for me. So I'm literally just plugging stuff in. And then what do I notice I'm missing? I don't know x. So I'm going to put 1 plus blank. Then 100 dx dt is 0.03 minus 100x, don't know it, and then dx dt is 0.03. Over 1 plus x, I don't know it, squared. Now, in all of those x spots, they had to give you information to find x. If they give you the wrong letter, I know that h is 50, can I go back and find x? What do I have to use, though? Not the derivative, but the original. So I want you to come back, use the original equation to find x when h is 50. Now, you did not have a calculator for this, but you can still do it. Where am I going to plug in 50 in this equation? It's the h. So I'd put 50 equals 100x over 1 plus x. How could I solve that? Could you cross multiply? So put this over 1. So I'd have 50 times 1 plus x, that's this diagonal, equals 1 times 100x is 100x. What would I do with the 50? Okay, most of y'all probably would have just done that in one step. That's fine. So 50 plus 50x is 100x. Uh-oh, my x's are on opposite sides. How can I get them together to be on the same side? Okay, 50 minus 50. Crap, the bell's about to ring. Then 50 is 50x. What's x? So put in 1, 1, 1. You're done. Okay, and now, do you have to simplify? No, don't simplify. Okay, the other big packet you have is the review we're doing tomorrow. If you want to look over it tonight, you can. It's not going to be due till your CBA, which will be Thursday. Okay? Good job.